Welcome back to our OpenStudio tutorial series. In previous videos, we've defined the building envelope, set up the weather conditions it faces, and created spaces. But now it's time to focus on what really happens inside those spaces, the activities that drive energy use. In this video, we start to explore how OpenStudio handles space occupancy and energy end uses. We'll continue this topic in the next video. Just like with constructions, there's quite a bit of data involved here. But you'll quickly see how OpenStudio's libraries and data inheritance make the whole process fast, consistent, and much less overwhelming than it first appears. Building end uses can consume energy directly, like lighting, electric equipment, or gas appliances, but they also add heat to the space. That internal heat gain affects how much heating or cooling the HVAC system needs to provide. Modeling these interactions is a core strength of whole building energy simulation. We'll also cover other key loads: sensible and latent heat from occupants through activity, breathing, and perspiration, infiltration of unconditioned outside air, and even the role of thermal mass from furniture and objects that store and release heat over time. Here's the reality check. Space loads depend heavily on occupant behavior, making this one of the most subjective and uncertain parts of energy modeling. Material properties are precise and measurable, but how do you accurately predict human behavior 8,060 hours a year? Will people arrive at the same time every day? How many will there be? What activity level? Will they turn off lights or plug in extra devices? Before you get discouraged, keep these important points in mind. First, one of the biggest values of energy modeling is comparative analysis. As long as occupant behavior stays consistent across simulations, uncertainty creates systematic error that doesn't ruin side-by-side comparisons. You can even test the impact of behavior changes if your assumptions are clear. Second, standards like ASHRAE 90.1, ASHRAE 189.1, and California's Title 24 provide prescriptive load assumptions based on real surveys. Using these standardized inputs improves consistency, even if they don't perfectly match every real building. Third, modern tools like OpenStudio support parametric analysis and Monte Carlo simulations, letting you sample uncertain inputs and report performance ranges instead of a single number, much more realistic and responsible. And the last key point, for existing buildings, calibrating the model against real utility bills is one of the best ways to reduce uncertainty, and OpenStudio makes that process surprisingly straightforward. But for now, we'll focus on using standardized inputs drawn from actual surveys. This ensures our results are consistent and repeatable. We'll go deep into parametric runs and calibration in later videos. So, let's jump right in and start assigning realistic loads to our spaces. Now we're diving into space types. One of the smartest ways OpenStudio helps you handle internal loads efficiently. Just like construction sets are built from individual constructions, which are made of materials, space types are composed of smaller building blocks that you can mix and match to describe all kinds of activities in a building. At their core, space types define a collection of thermal loads and schedules, things like people, lights, electric equipment, gas appliances, and more. Together, these loads consume energy and release heat into the space over time, as shown in this diagram. The beauty of space types is that you define representative loads and schedules once, and then apply them quickly and consistently to any space with similar activities. For example, an office space type can be assigned to one private office or dozens of open plan areas, all getting the same realistic occupancy, lighting, and plug loads without manual repetition. And just like with construction sets, you can import ready-made space types from libraries or other OpenStudio models. This lets you start with standards-based defaults, like those from ASHRAE 90.1, and then customize only what you need. Using space types keeps your model accurate, consistent, and fast to build. Now that we're comfortable with space types, let's talk about one of their key components: schedules. As we've seen, most internal loads like people, lights, and equipment vary a lot throughout the day and week, usually tied to occupancy patterns. To model energy use and heat gains realistically, we need accurate schedules that tell the simulation when things are on, off, or at partial levels. That's exactly what the Schedules tab is for. Take a look here in the OpenStudio application. You'll see buttons to create a new schedule set with the plus button, duplicate an existing one for editing, delete sets you don't need, and even a purge unused button to clean up any schedule sets that aren't being used in your model. It's great for keeping things tidy. The Schedules tab has two main sub-tabs. The one we're focusing on now is the Schedule Sets sub-tab, where we define collections of schedules that apply to a particular space type. In this example, You can see ready-made schedule sets for things like office break rooms, conference rooms, lobbies, and open offices. A single schedule set can cover up to 10 different categories: occupancy, lighting, electric equipment, infiltration, and several others. The great thing is, you don't need to use all of them. Simply add schedules only for the categories that actually apply to your space type. Within a schedule set, individual schedules can be unique or shared across different categories. For instance, in a well-managed office where people turn everything off when they leave, the occupancy, lighting, and equipment schedules might all be identical. But in a more typical setup, lights or plug loads often stay on at a lower level during lunch breaks or after hours. In that case, those categories would get their own slightly different schedules. Let's take a closer look at the actual schedule types you can create. Over here in the right-hand pane, you'll see the 6 types of schedules that OpenStudio supports. 3 of them, compact, constant, and year schedules, are directly based on the classic Energy Plus schedule objects you can read about in the Energy Plus documentation. They work exactly the same way behind the scenes. Next, we have fixed interval and variable interval schedules. These are perfect when you want to import real measured data, like logged occupancy or power use from a building. They're similar to Energy Plus schedule file object, but with a big convenience. The data lives right inside your OSM file, instead of needing a separate CSV. Finally, the most commonly used one in OpenStudio is the rule set schedule. This is actually unique to OpenStudio and doesn't exist in Energy Plus. You build it with easy-to-manage rules for different days, weeks, or seasons, and OpenStudio automatically converts it into a full year schedule for Energy Plus before running the simulation. The rule set type is what you'll use 99% of the time because it's intuitive, flexible, and keeps your model clean. You create and edit rule set schedules right here in the Schedules sub-tab. Take a look at the screen. These particular examples are fractional schedules, meaning their values range from 0 to 1. They act as multipliers on the maximum design level, whether that's the peak number of people in a space, the full lighting power, or the maximum electric equipment load. For instance, an occupancy schedule might be 1 during core working hours, full occupancy, drop to 0.5 during lunch, and fall to 0.1 or even 0 in the evenings and weekends. The same logic applies to lighting and plug loads, turning things on, off, or dimming them over time. The schedule editor you see here also supports visual drag and drop editing for many schedule types, making it super intuitive to build daily profiles, add weekend rules, or define holiday exceptions. We'll dive deeper into that editor in the upcoming videos. We've talked about space types and schedules. Now, let's move on to defining the actual loads that go inside those spaces. We handle space load definitions in the Loads tab, right here in the left-hand sidebar. OpenStudio organizes loads into several categories: people, lighting, electric equipment, gas equipment, steam equipment, other fuel equipment, internal mass, and hot water uses. Each space load definition describes a specific type of load, like general office lighting, desktop computers, or office occupants. Think of it as creating a template that specifies the power level, schedule behavior, radiant convective split, and any other details for that load. Please note that in this tab we're only defining these load types, we're not yet assigning them to spaces. We'll create space load instances later to actually add these defined loads to our space types or individual spaces when needed. This separation makes everything modular and reusable. Define a realistic office computer load once, and you can instance it across dozens of office space types without re-entering the data. Lighting loads cover a wide range of fixtures you might find in a real building. Individual desk or table lamps, rows of linear fluorescent tubes, emergency exit signs, and more. Electric plug loads include everyday devices people actually plug in, like copy machines, coffee makers, laptops, monitors, televisions, and so on. Gas loads, on the other hand, are things like commercial ovens, cooktops, or water heaters that use natural gas or propane. In OpenStudio, occupants and internal mass objects are also managed in the Loads tab, but they're special cases with their own behaviors. We'll cover them in the coming sections. Just like with other tabs in the OpenStudio application, you use the familiar buttons here, plus to create a new load definition, duplicate to copy an existing one for quick editing, delete to remove it, purge to clean up any unused load definitions from your model. Now, when you define the power for these loads, OpenStudio gives you 3 practical ways to enter the values, depending on what data you have and how the space is used. First method. Per unit, you enter the rated power of a single item and tell OpenStudio how many of those items are in the space. For example, 65 watts per laptop multiplied by 20 laptops in the open office. Second method. Per unit floor area, you specify the power density in watts per square meter or watts per square foot, and OpenStudio multiplies it by the floor area of the space. For example, 10 watts per square meter for general office plug loads across the entire floor. Third method. Per person, you define the power per occupant, and OpenStudio scales it according to the number of people present at any given time, based on the occupancy schedule. For example, 100 watts of miscellaneous electric equipment per person in a call center.